Cool. So we're talking about modeling with equations, and specifically we're just thinking about writing out word problems with algebra and then solving them. A lot of the times this is like the worst thing to do when you take a math class, I do understand that. But it's also a really important thing to do because that's the reason that you take a lot of these classes, is so that when you're presented with a problem that you speak in words, you want to be able to organize it logically. And that's what we want to do. So we'll look at a couple of examples. The main examples that I want to look at are interest problems and area problems, because those are two really useful problems. And your homework only has like 3 or 4 modeling questions to begin with, and 2 of those or 3 of those are interest or area problems. So we'll do that.
Are we still in 1 point or are we in 2?
We're still in 1. Everything up to test 1, which test 1 is Tuesday. No, not Tuesday. We don't have class Tuesday. Test 1 is, we'll find out, the 2nd. Which, yes, that's Tuesday, isn't it?
It's Wednesday.
Oh, that's Wednesday? Okay, so test 1 will be on Wednesday. So after tomorrow, probably, if we can get through the rest of the content tomorrow, then we will have Friday and Monday. Yeah, Friday and Monday for nothing but review. So we'll have 2 days for review for the test. I'll also give you all a practice exam for doing at home, a practice exam for doing in class. Both of those will be similar to the real exam, which will obviously be in class. All right. So if I want to model something with algebraic expressions or equations, there's kind of a 4-step process for doing it. Similar to the 5-step process I taught you for solving any math problem, more or less. Algebra is a little different. I can set up any word problem in 4 steps. So the main thing I want to do is identify variables. And when we go through and do these problems, I'll follow this 4-step method so that it kind of becomes ingrained in your brains as you go to do word problems as well. 2 is to translate the words into algebra. There's some key buzzwords when we're looking at problems that tell us what kind of operations or math we're going to be doing. For example, together typically means addition. Difference is going to mean subtraction. Groups of or times means multiplication. And into groups typically means division. We can also have words like of typically means multiplication. So 5 groups of 4, for instance, is 5 times 4. Stuff like that. So we'll pick out some of those key words there to help set up as well. We're then going to set up our model, which kind of goes right into part 2 here. So set up our model. And step 4 is solve, check, and interpret. That's probably one of the most important steps here. It gives you your answer, it validates your answer, and it gives a reasoning as to what your answer actually is. So again, when we go through and do these problems, we will see, we identify our variables, translate our word problem into algebra, set up the model for that problem, solve the model, check our answer, interpret the result. That's what you do anytime you use mathematics in the real world. You do this process more or less without realizing you're doing this process. And the last step is what you actually get out of this. For example, if you're working in an office somewhere and they ask you to do some sort of analysis, they just expect this end result. The interpretation specifically is the most important part. So we'll always make sure we interpret our answers into something meaningful. Our first example is we have a rental car company. They charges $30 a day, and they charge 15 cents per mile. So I could ask maybe two questions of this. What is a function for total cost given days and miles? And two, if the total was $108 after 2 days, how many miles did they drive? So this is a very reasonable word problem to see on a homework or a test or anything like that. I'm pretty sure your homework has something that's almost exactly like this problem. I don't know if anyone's gotten to the part of the homework that has questions from 1.7 yet, but the questions are exactly like this essentially. So the first thing I'm going to do is identify variables. First of all, how many variables do we have in this problem? 2. What are those variables? We can name them something. Well, variables don't have actual numerical values. Specifically, I should say, what do the variables represent here?
Days and miles.
Days and miles. I'm going to let D equal number of days, M equal number of miles. Cool. And I know translating these words into algebra, I have some amount of days, 30 times the number of days, and I have some amount of miles, where I charge 15 cents per mile. When I see per, that means times. So like, it cost me $7 per drink at a Braves game because they are ludicrous with their prices. So 7 times the number of drinks would be how much I spent on drinks, which is 0 because I smuggle stuff in. Same thing for this. 30 times number of days, 15 cents times number of miles. So it's important to label what your variables are and what they represent as well, so you kind of have an idea of how things are organized here. So now I'm going to set up my model. Well, this tells me the total number, or the total cost, I should say, given an input of days and miles. So this tells me I can tell you the total cost for the whole rental. All you have to give me are the days and the miles. And I'll spit out the total cost. So using this for specifically problem 2, because this gives us part 1, what is a function that models the total cost? Now for part 2, I was told the total was $108 after 2 days. That already tells me T equals 108 and D equals 2. How many miles means we're solving for miles. Cool. So I'm going to plug my stuff in there. T is 108. D is 2. And miles is what we're solving for. Alright. Pretty straightforward so far. It's just nice to kind of break everything apart. I'm going to put this 2 in parentheses so it doesn't look like the number 302. Alright.
And that's for the second part, C, D, N, and then that's just the first part.
This is all equal. Like this is the 108. This side corresponds to this. So I'm just keeping the left and the right hand side the exact same, just plugging in what I've been told.
Is that the formula that we're using to solve this, or is it?
Yes,
Okay.
this is the formula we came up with. That's the entire part of the section. Is typically you're given formulas, but sometimes you have to make up formulas that match realistically what's going on here. All right. I want to solve for m. How would I solve for m here? Yeah, so this is 60, and I want to move it over. So I get 0.15 m equals 108 minus 60 is 48. And then what do I do next? Divide by 0.15. So I get m is equal to 48 over 0.15, which comes out to 320. And that gives me the answer. So solve, now I want to check. I should check that if I plug this in, I'll get my correct number of things. So 30 times 2 days plus 0.15 times my number of miles, which I said was 320. And I'm going to write the units here. Equals, where's my calculator? 30 times 2 plus 0.15 times 320. And wouldn't you know it, I get 108. Now, interpret the solution basically just means write out what your answer means in a sentence. So I would say something along the lines of, if the total cost was $108 after 2 days, then the drive was 320 miles. Would be a way to interpret it. Any questions about this? This is a pretty straightforward example, more so of an introduction into doing this to kind of naturally guide you into the idea of setting up your own models and solving out these problems this way. No questions about this? I'll give you just a second to write the rest of it down. And bring a drink with me to this. I drank it all during lunch. So sad. Alright, everyone got this written down? Good. Next, I want to talk about interest. There's one specific formula that we need for interest that you will just be given. Interest equals the principal amount times the rate of interest times the time that interest was compounding. Principal here is the amount put in. And rate, we want to write from percentage into decimal. Who remembers how to convert from a percent to a decimal? Divide by 100. Right. So I'll put that in. Divide by 100. So for example, say I have $100,000 put into an account at 5% interest for 3 years. So now my question is, what is my total after? So I just write out my stuff. My principal, the amount I put in, I said is 100,000 here. My rate is 5%, which I want to turn into a decimal by dividing by 100. That will give me 0.05. Then my time, the amount it was in there is 3 years. So I'm just going to put 3. Typically when we discuss rates, the rates are more or less in terms of the year. I didn't write it, I should have written it. 3% interest per year. There we go. So now my rate is in terms of that. I could have said that it's in terms of compounding monthly, and then you'd have to do some different formulas for that, which we might get to in this class, but I'm not entirely sure. But you might get to an exponential system. All right. So what is my total after? Well, the interest, the amount I gain, is 100,000 times 0.05 times 3, which comes out to $15,000. This is my interest earned. Is that what the question asked for, though? No, it asked for what the total is. So then I have to add my interest to the principal amount, which that makes sense. If I put money into an account and it gains interest, I should have what I originally had plus the interest that I gained. So my total equals the principal plus the interest, which here is 100,000 plus 15,000, which is 115,000. There's my solution. I could check this by making sure that this is equal to my original plus what would eventually be 15%. And then interpreting this as my total amount in the account after 3 years at 5% interest yearly is $115,000. I could also rewrite this equation in terms of what the total is. The total after some amount of years is equal to let's see, principal rate time plus P, which is equal to P times 1 plus RT. That might be one that if you have to take any finance classes or anything like that, this is a lot of the times how it'll be written out. It'll be your principal plus the interest. It's often how it's written out. Any questions about this example? Cool. All right. Now I'm going to do a basic geometry problem. Actually, we'll do another interest problem first, and then we'll transition to geometry. And this is one that is directly from your homework. So you will redo this problem in your homework with different numbers. It says an amount of $10,800 is invested into 2 accounts. At 3.25% per year in one, and 4% per year in another. After 1 year, the interest is $384. How much went into each account? So I have my sum here, my lump sum amount, and I split it into 2 different accounts with 2 different interest rates. In doing so, I've gained $384 in interest, and now I need to work backwards to figure out how much was put into each account. Well, just writing out some of the stuff here, I'm going to have 2 equations for interest. I'm going to call one interest 1, which is the principal in the first account, times the rate in the first account, times the time of the first account, and interest 2, which is the principal in the second account, times the rate of the second account, and the time in the second account. I'm already given a lot of this information though. I'm given both of the rates, and I'm given the time. The time was just 1 year, so I'm just multiplying by 1 there. So this is whatever my P1 is, times my first rate as a percentage, which would be 0.0325, and then times 1 year. The second one, I have my second principal, which again, I'm not entirely sure what it is yet. My rate was 4%, 0.04, and again, just 1 year. I have no idea how to solve this though. I know that I can relate these. I1 plus I2 equals 340 or 384. But I still have 2 variables. And I can't really just solve this equation with 2 variables without plugging in information on one of them. I do, however, have a way to relate the 2 variables. What should P1 plus P2 add up to? 10,800. Right, I took my original amount, I split it into 2 principals. So it should be the case that P1 plus P2 equals 10,800. That means I can rewrite P2 in terms of P1. P2 equals 10,800 minus P1. That seems pretty helpful. The reason why it seems pretty helpful is now I can write this equation in terms of just P1 and solve for P1. I'm going to rewrite I2 real quick. P2, I said, is 10,800 minus P1. So 10,800 minus P1 times 0.04 times 1. All right. And now I have that I1 plus I2, I'm not going to rewrite it, it's right there. This should equal 384, so adding this equation with this equation should equal 384. P1 times 0.0325, I'm going to quit writing the times 1 because it doesn't change anything, plus 10,800 minus P1 times 0.04 should equal 384. Now I just have an equation in terms of P1, and I can solve for P1. I get 0.0325 P1 plus 10,800 times 0.04 is, I've got it on this sheet of paper over here. Is 432, then minus 0.04 P1 equals 384. So all I've done is I've expanded doing this multiplication here. This is 0.0325 P1, pretty straightforward. In a calculator, I would type 10,800 times 0.04, which would give me 432, minus 0.04 P1, and it's still equal to 384. I then just combine like terms. 0.0325 minus 0.04 is negative 0.0075 P1 equals, subtract the 432 to the other side, and I get negative 48. Then I just divide by negative 0.0075 on both sides. And I get P1 is equal to 6,400. So I've got P1. How do I get to P2?
Subtract it from the original.
Yeah, subtract this from the original principal. I just have an equation that cleanly relates the two. So P2 equals 10,800 minus P1, which is 10,800 minus 6,400, which is 4,400. And there's my answer. The principal in the first account was $6,400. The principal put into the second account was $4,400. So this seems like a really complicated example, but what really is going on here is I have two different things and something that relates them, right? Just like when we're doing any other problem with the 5-step process, I take what I know, what I don't know, and some way to relate them to each other. And then I can solve for the unknown. That's doing the exact same thing here. Cool. One last problem. We'll do this as an area problem, because this problem is also pretty similar to one you'll have in your homework. Any questions about this first?
Yeah.
Yes.
So that's finished. After you divided it and you got the answers. The answers are that's continuation at the bottom.
Yeah. I wish the whiteboard kept wrapping around so I could just keep going, but it doesn't, unfortunately. Any other questions? Did you have a question?
No, don't.
Okay. Are you sure? 100%.
No.
Rainey does not look as confident.
It wasn't about this. Another actor died. Tim Curry.
Tim Curry died?
Mm-hmm.
If y'all don't know who Tim Curry is, wow, that stinks. Tim Curry was the main actor in Rocky Horror Picture Show. If you've never seen it, that's a really good one, but a really weird one to watch. He played the original Pennywise. He was in the Clue movie. He's been in a ton of stuff. Wow, that really stinks. That is so sad.
That came out like an hour ago.
Wow. He was also pretty old. Wow.
Everyone but Voldemort, bro.
Everyone but Voldemort. No, it's crazy because I got finished. I put my phone on D&D whenever I record so that y'all don't see a bunch of notifications popping up. I got out of class yesterday, I turned it off, and the first thing I see is a text from my wife that says Dolly Parton died. And I was like, there's no way. I knew she was sick though, so that's sad. I didn't know about Tim Curry though. He keeps his private life pretty private though. He has for a while. Wow, that is so sad. All right, this will be our last problem. I have a square garden with 3 feet of sidewalk along the sides. If the total area of the garden and the sidewalk is 18,000 square feet, what is the area of just the garden? So this is useful for having a picture drawn out. So I've got my whole thing. My garden is surrounded by sidewalk. All right, and here's my garden of unknown dimension x. And I add 3 feet on both sides. So what does that make the entire length?
3 foot. Oh, sorry.
X plus 3 is what? Just x plus 6. And remember that area of a square is equal to just the square of the length. So this whole area is equal to x plus 6 squared. Well, I'm told what the entire area is. It's this 18,000 right here. So 18,000 has to be equal to this. How do I solve for x here? What's the first thing I do? Square root both sides. I'm going to get rid of that squared. So the square root of 18,000, let's see, on square root 18,000 is approximately 134. I just round to whole numbers because I don't like dealing with decimals. I should, yeah. So 134 is approximately x plus 6. And then I just subtract 6 from both sides. So I get x is approximately 128. I'm just going to leave it at 128 because I don't want to deal with decimals. So that tells me the length of the garden, but what about the area of the garden? Well, if this is 128 and this is 128 because it's a square garden, then the area of the garden equals 128 squared, which is 16,384 square feet. So this problem is deceptively easy, but also deceptively difficult, because the idea is, oh, I'm just adding 3 feet to one of my lengths. But you have to realize the 3 feet goes all the way around the garden. So I have to account for that when I'm doing this. That's why drawing out pictures is very, very useful. In step 2, I'm going to add a caveat to translate words into algebra and picture. It's very, very useful to draw out problems, especially when it's something physical like geometry. Or when you go to take trigonometry next semester, if you have to, a lot of those problems benefit a lot from being drawn out. Any questions about this example? That's all I have for y'all today. I let y'all out a whole 6 minutes early. I would have done it earlier, but I want to do the problems. If y'all have any questions, office hours tomorrow morning, or you can email me. I have the next hour free as well. And otherwise, y'all have a great rest of y'all's day.